Okay, let's dive right into this explainer. When you hear the name Albert Einstein, you probably instantly picture a wild-haired, untouchable genius, right? A guy whose brain was just wired entirely differently from the rest of us. But today, we're going to look at him through a completely different lens. We're looking at Einstein, the underdog, the rebellious student who failed exams, struggled to find a job, and yet somehow became the architect who completely changed how we see the universe. Now, what's really interesting here is how much his early life subverts everything we think we know. I mean, early on, Einstein was actually so slow to talk that his parents were terrified he had a learning disability. He definitely wasn't solving complex calculus problems in his crib. He was just a quiet, delayed kid who worried his family. But as we'll see, that quiet nature was really just a cover for an intensely curious mind. And that curiosity really kicked into high gear when he was 5 years old. He was sick in bed, and his father brought him a simple, everyday object, a magnetic compass. Not most kids would just look at it, spin it around, and get bored, right? But for young Albert, it sparked a lifelong fascination. He realized that no matter which way he turned it, the needle always pointed north. He later recalled this exact moment, realizing that, quote, something deeply hidden had to be behind things. Let's move to our first major chapter, the mystery of the compass. So why does this matter? Well, it wasn't just a cute childhood story. It literally birthed his entire scientific philosophy. The crucial point is that this simple toy taught him a profound lesson. First, you have a physical object, the needle, and it moves. Second, it's being pulled by an invisible magnetic field. And third, if you scale that up, unseen forces must govern the entire universe. This childhood epiphany is what drove his lifelong quest for a unified field theory. Which brings us to Section 2, Failing the System. Because understanding the unseen universe definitely didn't mean he understood the rigid structure of school. He absolutely hated the strict, militaristic memorization at his school in Munich. They demanded rote learning, just regurgitating facts back to the teacher. But Einstein craved independent, creative thinking. He found the whole regimen so stifling to his creativity that, eventually, he used a doctor's note to get out of there. He essentially dropped out. And it proves that success really isn't a straight line. Look at this. In 1895, at age 16, he actually failed the general part of his college entrance exam. He had to go to a different school just to finish his secondary education. Then, even after graduating in 1900, he couldn't get a teaching job. He applied for nearly 2 years and kept getting rejected, eventually settling for a lowly Level 3 assistant examiner position at the Swiss Patent Office. Okay, let's dive into the turning point. Section 3, the patent clerk's miracles. How does a rejected teacher working in a patent office change the world? Well, picture this. Einstein is sitting at his desk. By day, he's evaluating patent applications for mundane stuff like gravel sorters and electric typewriters. Not exactly a fancy university lab, right? He's just a civil servant. But in his free time, using just paper, a pen, and his imagination, he's fundamentally rewriting the laws of physics. In just one single year, 1905, this 26-year-old patent clerk published 4 groundbreaking scientific papers. Just one of these would secure a legacy, but he did 4 in a matter of months. And the sheer variety is just wild. He tackled light, proposing it exists in discrete packets, or quanta, which helped found quantum theory. He explained Brown motion, finally proving to the world that atoms actually exist. He introduced special relativity, completely changing how we understand space and time. And to top it off, he introduced matter-energy equivalence, the whole shebang, all at once. Let's zoom in on that last paper. Section 4. What is E equals mc squared? We really want to demystify the most famous equation in human history. The absolute beauty of this equation lies in its simplicity. E stands for energy, m stands for mass, which is just the amount of matter in an object, and c squared is the speed of light multiplied by itself. It simply defines the relationship between energy, mass, and the constant speed of light. But the real meaning here is a total game changer. Mass and energy aren't separate, unrelated things like humanity had always thought. They are interchangeable. They're 2 forms of the exact same thing. Mass is basically just super concentrated energy. Because the speed of light squared is such a massive number, it means that a tiny, practically invisible amount of mass holds a massive, almost incomprehensible amount of energy. This single insight became the foundation for the entire nuclear age. Let's move to our final section, a legacy beyond science.
This rebellious student's impact went far beyond the chalkboard. After reaching the absolute pinnacle of scientific fame and winning the Nobel Prize in Physics in 1921, his life took a really dark turn. With the rise of the Nazi regime in Germany, Einstein, a Jewish man and a prominent intellectual, became a target. His books were burned. He had a bounty on his head. So in 1933, he was forced to flee, eventually finding a safe haven in the US and becoming an American citizen.
As a global citizen, he absolutely refused to just stay in his lane. When he learned Nazi scientists might be trying to build an atomic bomb, he endorsed a famous letter to President Roosevelt warning him, an act that helped launch the Manhattan Project, which he later deeply regretted as a lifelong pacifist. He advocated fiercely for global peace, and having escaped horrific persecution himself, he recognized racism in America as a disease, joining the NAACP to fight for civil rights. So, what you should really take away from this explainer is that Einstein's legacy isn't just about his giant brain. It's about his courage and his refusal to conform. He didn't fit the mold of a good student, he didn't fit the mold of a traditional academic, and he certainly didn't stay silent in the face of political oppression. He let his immense curiosity guide him, even when the institutions around him told him he was failing.
Which leaves us with a final thought to ponder today. If a kid who was remarkably slow to talk, who hated rote memorization, and who failed his college entrance exams can grow up to rewrite the laws of the universe from a desk at a patent office, what unseen mysteries might your own curiosity solve? Will you let academic hurdles define you, or will you trust your own unique way of seeing the world?